Hello guys, welcome to Algorithms Made Easy. Today we will be discussing the question valid parenthesis. In this question we are given a string containing just the characters, that is open and close brackets of 3 types, and we need to determine if the string input is valid or not. A string input is valid only if the open bracket must be closed by the same type of brackets and open brackets must be closed in the correct order. We are given some examples with the problem and it shows which all strings are valid and which all are not. Now there are 3 hints given in the problem. The first hint states that a valid parenthesis expression is that a sub-expression of a valid expression must also be a valid expression. Hint 2 states that what if whenever we encounter a matching pair of parentheses in the expression, we simply remove it from the expression and this would keep on shortening the expression. And the third hint states that the stack data structures can come in handy here in representing the recursive structure of the problem. The basic idea that we get from the 3 hints is that we can use stack in order to solve this problem. So we will use stack. But how can a stack help us? So let's see how this problem can be solved using stack. Some of you might already know how to use stack and how to solve this problem with the help of stack. But there is a follow-up problem to this question which is mostly asked in the interview, and we have discussed that in the later part of the video. So if you are well versed with stack and how to apply it, you can directly skip to that part. For rest, let's see how we can use stack. Suppose this is the example given to us, that is, this is the string given to us and we need to find if this is a valid string or not. We'll start off with having a key value pair. The key will be all the closed brackets and the value will be all the open brackets. We'll also have a stack. Now we'll start iterating this string, and for every open bracket we need to push that into the stack. Somewhere in the string we'll encounter a closed bracket. Now when we encounter a closed bracket, we need to see if the top of the stack is the open bracket for this closed bracket or not. We can check that using the map that we defined. We know that these are the pair. So what we need to do is we need to pop this value from the stack and then move our pointer to the next position. We again do the same. These two are the pairs. So we pop them and then move ahead. And we will continue doing so till the stack is empty. If by the end of the string the stack becomes empty, that means this was a valid string and we will just return true. Consider at the end the bracket is square brackets and these are angular open brackets that is in the stack. So this do not form a pair. So as they do not form a pair, we will simply return false as the string is not valid. Now let's see how we will code this. So as discussed, we will have a stack and a map. Map will contain all the key value pairs. So we'll first define that. Now as we discussed, we need to iterate over the string. We'll take the current character into a variable. Now as discussed, we know that if the current character is an open bracket, we need to put that into the stack. Else we know that it is a closed bracket. As it is a closed bracket, we'll check if the stack is empty, because if we have a closing bracket right now and the stack is already empty, that means it is a single closing bracket and there was no open bracket in the stack right now. That means the string is invalid. So we'll return false. One other condition that we discussed already is if the map.get of this closing, that is the value is not equals to the top of it, so we'll return false. Otherwise at the end we just need to check if the stack is empty or not. If it is empty, then it is a valid string, otherwise it is not a valid string. Let's run all the test cases. So it is successful. Let's submit this. So it got submitted successfully. The time complexity is O of n and also the space complexity is O of n, as we are using stack in order to store the value. Now comes the follow-up question to this problem, which has been asked many times in the interview for many of the candidates. Interviewer in this problem, when you solve this using stack, will ask you to solve it without using any data structure to store the value. That is, they want a solution that uses no extra space. We know that when we need to improve one of the two complexities, we need to increase or degrade the other complexity. So we will now see how we can solve this problem without using any stack. So we'll change the same code, we'll remove the stack altogether from this coding. Now, why are we using stack? So let's again jump back to the example that we saw earlier. We were here. Whenever we encountered any of the closing bracket, we turned our attention to the stack and saw what bracket it holds at the top of it. So effectively, we were holding the top of the stack. How we can change our program to get this top element without storing all the values in the stack itself? For that purpose, rather than using a stack, we need a pointer. So we need to have a top pointer which points at what value should be the top of the stack. We are talking in terms of stack so that it is easy for you to connect what we were doing in the stack part and what we are trying to do over here without using any of the stack. So suppose we have the top pointing at this particular index, which was also the top element in the stack. So we check if the two pairs perfectly align with each other. As they do, from the mapping we can see that we need to move our pointer to the next index now. That part remains the same. The only part that changes over here is how to find that top, because we do not have stack. So the next top will lie in between index 0 to top minus 1. We are sure of that. In this example, if we need to find the next top, it will be top minus 1, and that will create confusion in your mind as to how will be the real top is calculated. So in order to clarify those doubts, we'll take a little complex example so that it is much clear to you as to how we are calculating the top and why we are calculating the top like that. So suppose this is the example and we are at this position and the top lies next to it. Since the character at the top and the index make a pair, we need to move the index to the next position. But before doing that, we need to find the next top, and the next top will lie to the left of the current top pointer, that is top minus 1. So how do we search the new top? As shown on the screen, the new top is at 0th position. So how do we come to know that? We'll have one more variable which we call right, starting from the index 0, and we have now top shifted to top minus 1. In this area shown in between brackets, we need to find the next top. Now we need to update the right pointer according to the conditions. So if the top is now pointing to a close bracket, we add 1 to it, and if it points to an open bracket, we subtract 1 from the right. I'll clarify why we are doing this and how this helps us in finding the top. Let's first apply these operations. So as we see, the top is a closing bracket, so we add 1 to the right. Now we decrement the top. Now the top becomes an open bracket, so we decrement the right. We again decrement the top. Now the top is again an open bracket, so we decrement the right, and the right now becomes negative, that is minus 1. The right pointer becoming minus 1 means that we have encountered from the top minus 1 till the new top position more number of open bracket than there are closing brackets, which effectively means that the top is now pointing to a open bracket for which we have not encountered any closing bracket, and that's how we find the new top. Let's see how we will implement this in our code, and it will be more clear to you when you see that. So as we know, we need to have a top which will be minus 1. Minus 1 telling us that the stack or the top is nowhere. That means that there are no elements. So this stack is empty can be now replaced with if the top is minus 1 at both the places. we pushing the value in the stack effectively means we updating the top to whatever index that we have. And now the most important part is finding the new top. So the stack.pop is nothing but it gives the current top value. So as a top contains the index, we need to find what character does it hold at this top pointer. So if it is false, then we are good, but if it matches, then we need to find the updated top. So we need to call a function which will give us the top. Now in order to find the top, we need two arguments. We need the string and we need till where we need to find the top value. And we discussed that it will be existing between 0 to top minus 1. We'll pass top minus 1 in this method. Now it all boils down to implement this method. So we'll start implementing it. As discussed, we will have a variable called write, and now till this index is greater than or equals to 0, we will apply the logic. So we'll take the current character into a variable. Now if this current character is a closing, if ch is closing bracket, then we increment the right, otherwise we decrement the right. And we discussed whenever the right becomes less than 0, that means we have found the value, and whatever value is there in the index we'll return it. We will be decrementing the I, and even if at the end we do not find any value, that means there was no top present and the stack is empty, and we directly return -1. Now in order to check if that is a closing bracket, you can check with the help of OR conditions, or what we can do is we can make this map a class level variable. So what we can do is we can take this out. Now all we need to do is map.contains key for this character, and that's how we implement it without using stack. Now let's run this code. Okay, so let's run it again. So it gives us the right result. Let's submit this. So it also got submitted, and ironically it is giving us a less runtime than the previous approach, but the time complexity of this approach is O of n square, because in order to find the next top, in the worst case we need to go all the way from 0 to n-1. The space complexity however becomes O of 1. Do let us know your thoughts in the comments below. Thanks for watching the video. See you in the next one.